I'm on 15 now. 15 is a dot product. Remember how to find dot product?
No, I forget.
It is on your sheet, but I think, yeah, right here. Dot product. A times C and B times Z. It's just you multiply the first two numbers together, you multiply the second two numbers together, and then you add your answers. That's it. So, if I'm looking at this, my first two numbers are 1 and 8. So 1 times 8 is 8. And then my second two numbers are 2 and -1. Multiply those together, it's -2. Add those together, I get a +6, choice C. So dot product, super easy if you know what you're doing. Multiply the first two numbers, multiply the second two numbers, add the answers. Signs are important though, so make sure that you keep track of them. 16, find the angle between the pair of vectors to the nearest tenth of a degree. Huh? I just did 15, the dot product, yeah. 16, find the angle between the pair of vectors. So that's this. Dot product and vector angle. Vector angle is the angle between the two vectors, okay? So I'm going to use, these are the same formula, it's just this one solved for cosine of theta. So since I'm trying to find my angle, I'm going to use this. So what do I need? I need the dot product, u dot v, divided by the magnitude, the product of the magnitude of each one. So I have some math to do first, okay? First, let's figure out the dot product. So on 16, again, that means multiply your first two numbers together. So that's 35. Multiply your second numbers together, that's -56, and add them together. So 35 and a -56 gets me -21. So there's the top of my fraction. On the bottom, I need the magnitude of each one of these. And then I'm going to multiply those answers together. So if two sides of my triangle are, these are right triangles though. So if two sides are -7s, what must the third side be if they're right triangles? If two sides are the same, that third side's gotta be, well, I mean, you can think about them as positives because it's really, I'm really doing a squared plus b squared equals c squared, right? Right? And that's just a and b. But you already know this. It's a special right triangle.
Oh, it's
Yes! 45, 45, 90 triangle. If two sides are the same, then the hypotenuse is just the one of the sides times √2. I don't have to worry about the negative part because remember, it's a squared plus b squared.
So it would be 7 √2?
Yes, 7 √2. So that's the magnitude of my first one is 7 √2. And then I just need to multiply that by the magnitude of this one. So if one's 5 and one's 8, so 5 squared is 25, plus 8 squared is 64. That gets me the square root of 89. So that one's not any kind of special thing. I just had to do it out. So now I'm here. What is it, cosine? Yeah. Cosine of...
Yeah, what'd you get? You did...
a squared plus b squared.
So...
Equals, yeah, square root of a squared plus b squared. It's right here too. You don't have to memorize it. It's right there.
I got √39. A squared plus b squared.
Did you square, well, -5 squared is 25, right?
25 plus 64.
Yeah,
89.
yeah. So the magnitude of this vector is square root of 89. All right, so now I can have the calculator do all this for me. Remember, you want inverse cosine, so second cosine, and then I need to type all this in my calculator carefully. So I want -21 divided by, and I want all this in my denominator, so I would put all that in parentheses. So parenthesis, 7 square root of 2, close the parenthesis for that, times square root of 89. Close the parenthesis for the square root, and then close the parenthesis for the denominator, and then close the parenthesis for the cosine bit.
I got the same picture.
You're missing parentheses, I bet. Yeah, they have 3 parentheses at the end. You do?
Did you have them in the beginning?
So if you keep getting syntax error, do more pieces by, like, do them out. So, for example,
Look at this. You can't even look. I did the
Do
exact same
negative
thing.
21 divided by 7. Or figure out. Can I go fill this up?
sure. Oh. Yeah, okay. See how this, when you do, when you do 7 root 2, see how the square root keeps going?
Yeah.
It's
How do I
taking this-
stop it?
So, I'm going to clear it, right? So when you do 7 square root 2, you need to hit the arrow to come out of it.
Oh, okay.
Otherwise, it's going to take the square root of everything else
Yeah,
that
I
you type
know
after that.
That's why I was screwing you up.
Yes. Not all calculators have that setting, so you can just find an, I don't know how to undo it either. Okay, so there's that one. I forgot what my answer was. Oh, it's 103. There we go. Choice C. Okay, 17. I have U and V and W. So here's what they want. They want me to do U dot V and add that to U dot W. So I need to do 2 dot products. So U dot V. So make sure you're using U and V and find their dot product. So that'd be 40 plus 42. So that's 82. Plus whatever U dot W is. U dot W would be 55 plus 14. That's 69. So 82 and 69 get me, oops, 151, choice C. All right, so let's now look at, we have our short answers. I hope we can get these right. All right, a pilot wants to fly on a bearing of 67.2. By flying due east, he finds that a 57 mile per hour wind blowing from the south puts him on course. Find the airspeed of the plane. So, guys, are you following what's going on?
Yes.
The pilot wants to fly at 67.2, a bearing of that. But because of the wind, he basically has to fly his plane due east. And then as he's flying east, the wind is going to push him on course. So, what we need to figure out is his speed, okay? So, let's draw this. Here's the plane. He's flying due east right now. I'm trying to figure out the speed at which he's doing that. There is a wind coming up from the south. So there is a wind that is pushing him at 57 miles per hour coming up from the south. What I know is that this puts him on a bearing of 67.2. This is a right angle because that's coming up from the south and that's east, so that's helpful.
Do pilots actually take this into consideration?
Oh, yes, all their computers take this in, but they need to be able to do this also because there's, like my pilot friend, they have to do all sorts of simulations without computers.
Really?
Mm-hmm. Because what if it goes down? What are you going to do?
Fly a different jumper off when there's not computer.
Okay, so does my diagram make sense to everybody? Because remember, your questions are just like this, so you're going to have to make your own diagram tomorrow. Okay, great. So I'm trying to find this. I think I have enough information to get there. Yeah, because remember, that's just 90, so let's just do 90 minus 67.2. 22.8. And then, guys, what can I do to find x? Too much work. Too much work.
Pythagorean Theorem.
Too much work.
What?
Can't I just do tangent? Right? Tangent of the angle, opposite over adjacent. Yeah, I got this. Tangent 22.8 equals opposite 57 over adjacent x. There's my equation. Solve it and you are golden. 57 divided by tan of 22.8. So the airspeed of the plane, 135.6. All right, next one. Okay, so we were talking about these yesterday. Zach, did you see my answer to your question? Okay, good. So if anybody didn't get that answer, I have a hill, right? It's making a 27-degree angle with the ground, or with the horizontal, right? I have a boat. Here's my boat, right? Whatever. There's my boat. Basically, the boat straight down, okay, is going to be a force that's equivalent to the weight of the boat. That's gravity pulling on the boat. That's the entire weight of the boat. Huh?
The boat is going down.
Well, I have to figure out what force will keep the boat from going down.
Why would there be a boat?
Oh no, it told me. It told me the force that's already there. Oh, well, it's on a ramp, right? Okay. So, that's what I'm trying to find. How much does a boat weigh? I don't know. That part is x.
That's what you gotta find. You just take the force and divide it.
Well, hold on now. So, Zach's question yesterday, we had this other one that was perpendicular to the ramp,
Yeah.
right?
And then you found out that it's 27 degrees.
Well, this is 27 degrees, that's true. But this line right here, that's the force that the boat is pushing on the ramp with. So think about this. If the ramp were flat, girls, can you quiet down, please? Thanks. So, if the ramp were flat, wouldn't the boat be putting all of its weight on the ramp? So these two would be the same. The weight of gravity and the weight it's putting on the ramp would be the same, right? But it's not. It's on a slant, right? So shouldn't this be a little less? Not all of the weight is being put directly down on the ramp.
How do you know the angle between x and the perpendicular?
This one?
Because if it was flat and then, oh no.
It always is. The force.
What did you write? Hey, what?
Oh, sorry.
And we gotta charge it.
So I have the ramp,
Did I say 25?
27. And that angle is always the same as the little angle right here.
Oh, okay.
Yep. So basically what we have, we're going to draw our parallel line, and we have a little right triangle in here. I should have made that a little bit longer. So here's a little tiny right triangle. Here's the other bit of information. They're telling me that there is a force that's holding this boat up that's 540 degrees, or 540 pounds.
That's the brakes.
Right. So the brakes are applying 540 pounds of force to stop this boat from rolling
The boat
away.
weighs 539 pounds.
No. Oh, wait. I don't know what the answer is yet.
Well, think about it. It was 540.
No, the
But
brakes
it's
are
not-
strong. The brakes are stronger than the boat needs it to be.
This is the same as this. This is the force that's trying to make it go down the hill. This is what's stopping it, 540 this way. So I have 540 working this way trying to pull it down.
Yep.
Right?
No,
Okay.
'cause then wouldn't it be,
But now I have enough to solve for x. Can I just do sine? Sine of 27 equals opposite 540 over hypotenuse x. So 540 divided by the sine of 27 gets me 1,189.5 pounds. So that's the weight of my boat.
What? That don't make sense.
Why not?
because if the brakes can hold 540 pounds of pressure, then wouldn't the boat just go?
It's like holding double.
But it's not, no, think about it. If it was flat, would the brakes need to work at all?
No.
No, right? Because it wouldn't move.
But they're on a
So
hill.
if I, right, but, and it's not, if it was perfectly vertical, I would need to support all of that weight, right? But I don't need to support all of it. I'm only on a little bit of an angle.
Oh, okay, I got you.
Like
So-
even at like a certain angle, the brakes start to support eventually all of the weight. It doesn't necessarily have to be 90 degrees from a physics standpoint. I would think that at a certain angle, it is no longer
Well,
support, the ground is no longer helping you at all. Gravity is 100% pulling the boat down at a certain angle.
Yeah.
I would argue that it doesn't have to be like this.
Right, because it's
It could be
eventually going to
like-
fall. But
that
we're
could go
also
up
ignoring
with
friction.
Okay.
Right. Yeah, we're ignoring friction completely in this. So I think that's where that comes into play. But you're right.
So basically, this is complete bull cock.
No, it's not. All right, 20.
Bull tag.
Woo! I only have 10 minutes. Hurry. One rowed pulls a barge directly east with a force of 48. Another rowed pulls the barge north with 87. Find the magnitude of the resultant. Okay, this one's not so bad. East, 48.
What number is this? This is
20, and north 87. I need the magnitude of the resultant. So remember, to find that, I have to create my parallelogram. I'm looking for this. Since I have north and east, or whatever, these are 90 degrees, right? So I basically have a rectangle, and I'm looking for the length of the diagonal of the rectangle. Well, that's pretty easy. Can I just do law of cosines again? Oh, wait, no. That's so stupid. Why wouldn't I just do Pythagorean Theorem?
yeah.
Since I'm lucky enough to have right angles. Dopey. I did law of cosines when I did it before, too. Usually, though, we're not lucky enough to have a 90-degree angle there. But I do this time, so why not use it to my advantage? So, the square root of 87 squared plus 48 squared. 99.4. Right? So there's the magnitude of my resultant.
What, 90? That's it?
On your test tomorrow, I don't know if that's a 90-degree angle or not, because remember I just hit new numbers. Maybe it is, maybe, well, probably, because it doesn't change the words, I don't think. So you're probably still going to have one east and one north. But just in case you don't, if that's not 90, you got to do law of cosines. All right. So 21 is another one of these ramp problems. So I have a ramp that's inclined at 32.8. I have a ball. So it's going to have the weight of gravity straight down. And it's going to have the force that's being applied to the ramp perpendicular to the ramp, right? So the weight is the same thing as the one that's going straight down. That's the gravity one. That's 25.7. What is the minimum force required to prevent a ball? So I'm looking for this value. So I'm trying to stop this ball from rolling, but remember that's the same as this value. I know this little angle right here is the same as this one, 32.8. And I'm looking for that. Yep, I got my little right triangle. I have everything I need. Opposite hypotenuse, so it looks like I'm doing sine. Sine of 32.8 equals opposite over hypotenuse, 25.7. Do that math out, and I should get my answer. Lickety split. Sine 32.8 times 25.7. 13.9. Yeah. With 21, I'm done.
Oh, that's
And then the last one I have to do is 22. I'm trying to cross a 207-foot wide river in a boat. The boat can travel 31 miles per hour relative to the water, and that the current is flowing west at a rate of 7. What bearing should be chosen so that the boat will land at a point exactly across from its starting point? All right, so let me first make sure that you understand the situation. Whoa. Here's my river, okay? You're here, so let's call that A, and you're trying to get to B, which is directly across from you. But the river, I don't know of many rivers that just sit still. Don't they all flow? Yeah, so this one is flowing, what, west at a rate of 7 miles per hour. So that means if you try and just row straight across or motor straight across or whatever you're trying to do, you're not going to end up at B. You're going to end up somewhere over here, right? So basically what I need to do is figure out, all right, well, at what bearing should I take off so that by the time I get across, I actually end up at B? You follow me?
I'm digging.
Okay. If you are like a ferry person going across the Mississippi River, you bet your bottom dollar you better know what you're doing. Imagine how mad you'd be if you got on the ferry and you ended up over here and there's no way for you to get off. What the heck are you going to do? I don't know. Any hoosers. So, basically, I'm going to take off this way at 31 miles per hour. The river's going to push me this way at 7 miles per hour. I need to figure out what bearing this is. Right? Straight ahead would be 0.
So you have, it's a 90-degree angle.
Yeah. So, can I just use what?
Wait, you know this? The distance between is 207 feet.
Yes, but these are, it's not really the same units because these are speeds.
So you have two outside.
But I don't even need it.
You have
Can
two
I?
outside angles and one inside angle. You can use the law of sine or law of cosine.
If you take away law of and just say sine, you're right.
Sine.
Don't I have opposite and hypotenuse? Can't I just stop at that angle?
I need to use something.
Yeah, sine of my angle would equal opposite over hypotenuse. So don't I just ask my calculator to do inverse sine, second sine?
Inverse sine of 7.
Equals
That's it.
opposite over hypotenuse.
Yeah. So that bearing should be 13 degrees. That's it.